So, good morning to everyone. So, till now we discussed what will be the influence of an external field on our distribution function. Okay. So, under the basis of that discussion, we had obtained this expression. Okay. So, basically, if we apply some kind of external field, then particle velocity coordinate and position coordinate changes. So that's our drift variation. Okay. Now, basically, what happened that if you don't talk about this external field also, then also there is some another kind of effect also. Okay, which makes particle velocity coordinate to be changed. That is collision variation. Okay, that is collision variation. Okay, so this, if you consider this collision variation factor also, then also we will see that particle having velocity coordinate something, it will change to something. Basically this happened due to some kind of scattering potential. Okay, so let us consider particle having velocity coordinate is bx by bz. So after collision it changes to some another kind of velocity coordinate, same as in case of drift variation. We had seen that how velocity coordinates are changing under the influence of some external field. Okay, position coordinate also changing, that is another thing. Here basically we are concerned about this velocity coordinate, how this is changing. Okay, so this effect also change these velocity coordinates. Okay, so let's go in more detail. Okay, so this term measures probability. Okay, basically say we have 100 number of particles having velocity coordinate vx by bz. So after collision, say 10 number of particles changes to this velocity coordinate vx prime, vy prime, and vz prime, and rest 90 number of particles just remain same. Okay, so number of particle after collision whose velocity coordinate changes is 10 by 100. Okay, so similarly, this factor also measures that only. Okay, this measures that number of particles having velocity coordinate vx by vz, which changes to vx prime, vy prime, vz prime under collision. So this factor calculate probability that number of particle having velocity coordinate vx by vz, which changes to vx prime, vy prime, vz prime after collision. So how many number of particle changes? Okay, so this factor calculate that. Okay, now this Vx, Vy, Vz particle having velocity coordinate, this velocity particle having this velocity coordinate. Okay, so after collision, it may change to some other velocity coordinate. Okay, so this basically this velocity coordinate will be a variable. Okay, will be a variable velocity coordinate, but it will not equal to this Vx, Vy, Vz. Okay. Okay, so we can see there's this collision probability. If we write Vx, Vy, Vz instead of prime, then it will be 0. Okay, Vx, Vy, Vz, comma Vx, Vy, Vz. It simply signifies there is no collision. Okay, so basically we are considering particle having velocity coordinate this. After collision, it changes to some other arbitrary velocity coordinates. Okay, so if we consider if we are going to consider all range of those variable particles, all range of those particle having velocity coordinate this, so we do just integration. Okay, in this integration we can see that particle having velocity coordinate vx by vz to change to some other variable velocity coordinate vx prime, vy prime, vz prime. So we are considering those all particles which changes its velocity coordinate after collision. So this is that it calculates number of particles whose velocity coordinate changes from vx by vz to some other velocity coordinate. Okay, so this is just in probability. Okay, and we know that probability have to be multiplied with total number of particle having velocity coordinate vx by vz. So this distribution function plays that role. Okay, it simply plays the role that number of particle having velocity coordinate vx by vz. Okay, when we multiply with this, basically this is a probability that number of particle whose velocity coordinate changes to this velocity coordinate under collision. So just when we do just multiply, then we'll obtain number of particle whose velocity coordinate has been changed to this velocity coordinate. Okay, so this that, but basically this velocity coordinate which we are discussing is also has been obtained due to some kind of collision. Okay, So we can say that particle having velocity coordinate vx prime v double prime vy double prime vz prime double prime, after collision it changes to this, and after again collision it changes to some other variable velocity coordinate. Okay, and even this will be also a variable, so it can be anything, but after collision it changes to this. Okay, and and so now let's discuss about this collision term. Okay, so what happened is that, say we are considering a group of particles. Okay, so these are the group of particles having velocity coordinate bx1 by1 bz1 double prime. Okay, so this group of particles,